Welcome back after the break. So we're busy discussing the paragraph question 2.3.5, and the question states we need to look from a climatic point of view. Why is the location of the farmhouse not really ideal? Now let's just go back to our diagram. Now if you look at the farmhouse, you can see it's basically based in a valley. There's the dam situated over there, and the farmhouse is situated down the bottom of the valley. Now, why from a climatic point of view is this not the correct location? Now, before I'm going to answer the questions, let me just quickly draw a diagram for you, because let's see what happens during nighttime in a valley. Now, we know we experience valley breezes during nighttime. So what happens? During night times, terrestrial radiation, Earth cools down, we got sinking air, we call it katabatic breezes that we experience during the night time. So what does a katabatic breezes do? It collects down the bottom of the valley, it displaces the warm air, creating a thermal belt or inversion layer. And down at the bottom of the valley, we experience a frost pocket. So either way, you want to stay far away from the frost pocket, because not only are your crops going to suffer because of very cold conditions, temperature is going to drop below 0 degrees Celsius, but you yourself are going to experience very icy cold conditions. And it's going to make farming incredibly difficult because many crops are not frost resistant. So let's go and answer that question quickly after my explanation, looking at the diagram. And what can we say? Just need more space to quickly write. We can say that katabatic breezes are being experienced at night time. Katabatic breezes experienced at night. So that creates cool conditions. And we can say what happens then? The cold air collects in the bottom of the valley and bottom of the valley. And then obviously, because of the cold temperature, a frost pocket forms. Just say a frost pocket develops in the bottom of the valley. Okay, crops might die because they might not be frost resistant, and they might experience radiation fog is another reason. And that leads to, it reduces visibility. And cold conditions can have a negative impact on your health. And there is no advantage of the thermal belt. So basically, if we go back to the diagram, what do we experience? Because the farmstead is situated down there, it's going to have a very negative influence, because the cold air is going to collect down in the bottom of the valley. It displaces the warm air up, creating the frost pocket where temperatures can drop below 0 degrees Celsius. Now, unfortunately, for any crops over there, not only do we have many crops that's frost resistant, it's going to have a negative impact on the crop being produced, and it's going to create radiation fog that will create intervisibility where we won't be able to see very clearly down there. Okay, let's continue with our next questions. Okay, 2.4. Refer to figure 2.4, which shows a synoptic chart. Now, before we're going to look at the question, let's go and look at some answers over here. Clues over here, that's what I meant. Now, obviously, if I look at this synoptic chart, my first clue that I see is this high pressure over the interior. And when there's a high pressure in the interior, That high pressure is known as the Kalahari high pressure. Immediately I know it's winter. Another reason why I can tell you that we experience winter, if I look at the weather station models of Pretoria, if you look at, they've got a maximum temperature of 19, but more so, look at the cloud cover at the weather station model. 0% cloud cover. Why is that? Because of sinking air, subsidence taking place. And if we look at the dew point temperature, it's way below freezing at -6. Now, another reason that I know versus winter, look what's influenced the Western Cape, what's approaching. We have a mid-latitude cyclone approaching from the west. And then what I look to see over here at the L, I see a coastal low pressure situated over there. Now grade 12s, at X, look at the weather station models. 31 degrees Celsius. Now how is it possible for 31 degrees Celsius during the winter? What is the place over there being, what's being experienced over there? Over there, berg winds are being experienced. And we're going to look at the questions now. So without even looking at the questions, we can immediately see, okay, we've got a winter synoptic chart. We've got the Kalahari high pressure system over the interior. We have a mid-latitude cyclone approaching. We look at our weather station models, look at Pretoria, it's quite cool, moderate temperatures, absolutely no cloud cover. And then we experience berg winds down where the coastal low pressure is. Okay, clear indication of winter conditions. Now let's quickly go and have a look at the questions. Identify the high pressure system V. And we've done that. That is known as the Kalahari high pressure system. Identify the low pressure system at weather station X. Now let's just quickly go and have a look at that. X, that's a coastal low, and that basically causes the berg wind conditions. So that is a coastal low pressure. Okay, what do we know? Low pressure moves all along the coastal line of southern Africa. Refer to the high pressure system at V. Give one reason because of the existence for this high pressure system. Now, first of all, it's stable air. It happens during winter. It exists due to subsiding air. And the main reason why, what you've learned, global air circulation, subtropical high pressure belt that exists over southern Africa. Okay, and we can also mention that it's a semi-permanent anticyclone. Now, how does this high pressure system influence weather conditions over the interior? Now, if you live in Johannesburg or in the Northwest or in the Free State, you will notice that we have clear blue skies during winter. Clear skies are being experienced during winter. We experience dry air. We don't experience any rainfall. No rainfall. We experience frost during night time because of the cold temperature. And little winds. And another point that we can make, there's a massive, large temperature range. Now, what is temperature range? You take your maximum temperature and you subtract your minimum temperature. The reason why is because it warms up during the day. But at night time, the temperature drops well below freezing, and that's the reason we experience frost. And because of terrestrial radiation, that's the reason why it cools off so quickly, because of the clear blue skies. Now, if we look at question 2.4.4, refer to the low pressure system at weather station X. Give a reason for the wind direction at X. Now, let's just quickly have a look at that. Now keep in mind, look at the wind direction. Very importantly, it's a low pressure system. We're on the southern hemisphere. What is the wind direction over here? Okay, the low pressure turns in a clockwise circulation in the southern hemisphere. So if you go and look at our question, give a reason for the wind direction at X. It's because of it rotates clockwise around the coastal low. Because it's a low pressure system, and low pressure systems moves clockwise in the southern hemisphere. Okay. Explain the high temperature being experienced at weather station X. Now, the reason why is very similar to the question. If you look, there's a high pressure over the interior where Pretoria is, and there's the coastal low pressure. So what happens? There's subsiding air. Now, you know air that moves, wind is air that moves from a high pressure to a low pressure. So what happens? This air moves down the escarpment to the coastal low pressure. What happens? Keep in mind, this escarpment is roughly 1,600 meters above sea level. Now, when you move down the escarpment, the temperature is going to increase. It's descending air, and we say it heats up adiabatically. And that's the reason, if you look at it, look at the warm temperature being experienced, 51 degrees Celsius, because of this Bergwind conditions. So over there, I've just drawn a diagram. Basically what happens, there's a high pressure over the interior, you can write that down, and the air moves from a high pressure to a low pressure down the escarpment, and because it's moving down the escarpment, it heats up adiabatically, and that's the reason why there's an increase of temperature taking place. Let's go look at our next question. Okay, figure 2.5 is a sketch showing us drainage patterns. Now, quickly, very easy to identify it. If you look at A, first of all, it resembles the branches of a tree. And if you look at B, it joins at acute 90-degree angles, as you can see over there, and over there. Okay, now we've learned in our theory that we need to know the characteristics and how to be able to identify these drainage patterns. Let's quickly go and have a look at the questions as being asked. Now the first question, what is a drainage pattern? It's the way in which a stream is arranged within a drainage basin. So what is a drainage pattern? The way in which a stream is arranged within a drainage basin. Name drainage pattern A and B. I'm going to do it on there. A is dendritic and B is rectangular. Okay, we've mentioned dendritic and rectangular. Give evidence from the graph to support your answer. First of all, the dendritic resembles the branches of a tree. And another reason, the tributaries joins at acute angles. And if you look at the rectangular pattern, okay, the river's tributaries join at right angle bends, and the tributaries join the main river at 90-degree angles. Okay, question 2.5.4. Compare the underlying rock structures for the drainage patterns A and B. Now keep in mind A is the dendritic pattern and B is the rectangular pattern. The correct answer for A, the underlying rock for dendritic patterns are uniformly resistant. It means it's the same type of underlying rock, like homogeneous rock. And if you look at the rectangular pattern, develops usually on joints, on well-jointed cracks, cracked rock. So they are not uniformly the same. Okay, draw a simple and labeled plan view sketch of a drainage pattern that will develop in a folded landscape. Now that is quite simple. It's usually your trellis pattern. As you can see, it's lines joining parallel with one another and they're flowing with the main stream, and there's your joint over there, and as you can see they join at acute 90 degrees angle. Okay, if you look at 2.6, we have a photograph of a river channel over there. Now, if you look at the photo over there, I can see braided stream situated over there. The stream is meandering. As you can see, there's cultivated land in the floodplain and trees over there. So that's my first tip. That will definitely tell me this is also in the lower course of a river, because there's deposition taking place, as you can see with the braided stream situated over there, the small island that develops in the river channel. But let's quickly go and look at the questions. Give two pieces of evidence that show that the river channel is in its lower course. Now if we go back, I've just mentioned it, we can see the stream is braiding, the river is relatively wide, and most importantly, look how flat the gradient is. There's no really steep hills or relief over here. So let's quickly write down the correct answers over here. What can we say? Because this braided stream, it's a gentle gradient. We can say there's no turbulent flow, it's only laminar flow. And we also mentioned that the river is meandering, taking place. And we can see the floodplain. Okay, now refer to the confluence at A. What is river confluence? Let's just go back to the diagrams over there. And what happens over here, Great Charles? Confluence is where two rivers join. Okay. What is river confluence? Is where two rivers join. Okay. Now, why is flooding likely to occur at the river confluence? It's because of the velocity, no, it's the volume of water that increases. So, I mean, two streams converge. And that means there's going to be an increase of volume of water. And that's the reason there's a much better chance that we might experience flooding. After the break, we're going to continue with 2.6.3. Don't go anywhere. Stay tuned.